Hello and welcome. Building a trading strategy with Python. This video is going to be both interesting for beginners, but also more experienced people. Reason behind that is the strategy we are building is super straightforward. It doesn't get easier than this, but we are building it in a way that it's scalable. So we are not using any loops, for instance, but just array-based operations. So it's going to be interesting no matter what skill level you are. And I'm keeping it as simple as possible as always. So what is the trading strategy? Trading strategy, super straightforward. Time, series, momentum. Both thoroughly researched in academics, but also institutional research. The strategy is just you make a buying decision based on the past return of a stock. Simple example, you take a look at the Apple stock and take a look at the last year's return. You check, okay, it's 10%-ish, so you buy the stock and hold it for a certain holding period. The absolute standard way is to take a look at the past 12-month returns and then hold the stock for 1 month. Side note, there are two main momentum strategies. One is time series momentum, where you just consider a single stock and the past performance. This is what we are doing today. And then the second one is a cross-sectional momentum strategy, where you consider a bucket, so a whole portfolio of stocks, and just pick the best ones based on the past returns. Slightly more complicated. I'm open to do that in the future. But in this video, we're going to do time series momentum. So again, just the past performance of a stock, buy it based on the past performance, hold it for 1 month. As already said, I'm making it scalable, so you can change the past return time horizon and also the holding period time horizon. So let's get into the coding part. We need two libraries, YFinance to pull stock price data and import Pandas for data handling purposes. That's already it for libraries. And then I'm just going to define a ticker here, and we are going to take the Apple stock just as an example. You can play around with whatever stock you're interested in. You can also scale that up for multiple stocks. I'm just covering the one stock example in this case. Then we're going to pull prices for this stock. So just going to pass the Apple stock here, and we are just starting 10 years back. Maybe I'm getting old, but taking a look at this date and thinking about this is 10 years ago just makes me sick. I don't know about you, but this is actually 10 years ago. So we are going to take a look at the last 10 years, and I'm just pulling the close price. So you see, super straightforward. We're just getting a time series here with a date index going from 10 years back until today. So Apple back then was $25. Today it's 222. And now we need to struggle with this data, or struggling is probably not the right word, but we need to manipulate this data so we are getting it in the right format. And that is, we need to resample it to monthly data. Why? Because just to recall what I said in the beginning, we want to take a look at the past 12-month return and then take a look at, based on this past 12-month return, how the stock performed over the subsequent 1 month. So first thing we are going to do is to resample this data frame into a monthly data frame. So currently it's daily prices. So I'm going to call that MTLDF and use resample, pass monthly, and then just take the last price on a given month. So how does this look like? This is looking like this. So now you have end of month prices for Apple. So super nice already, because now we basically have everything to design the strategy. Just to give you an idea how this or where this data is coming from. So if you take the daily data and just screen for the end of January price 2015, you will get exactly this price. So 26.09. So this is the end of January price for Apple. And to get the monthly return now, it's super straightforward. You just take the relative change from one month to another. So you just apply a percentage change on this monthly data frame. So percentage change over 1 month, and then obviously you are getting the first row returned as an NaN value because you cannot calculate this versus the previous month because it simply doesn't exist. So I'm just dropping it off immediately, and then you get monthly returns. So let's store that in monthly red, and with that you're just getting the monthly returns. So this value, once again, is just the February end of month value divided by the January end of month value, and so on. All right, so you are getting monthly returns, which is already a very nice thing to have. Same logic you apply. So you just want to get the 12-month return now, and the percentage change function has a window parameter which you can pass. So the easiest thing to do here is just taking the monthly price data frame and just calculate the 12-row return. With that, you're just getting the 12-month returns, and then you're getting the first 11 rows as NaN values in that case, so you just drop them off as well. So what is this doing? This is just calculating our 12-month return. So just to be crystal clear here, this value is minus 15.5%. And where does this value come from? So what does this row tell me? This is just the 12-month return from this date back, ending up as minus 15%, meaning the Apple stock was dropping from January 2015 until January 2016 by 15%. So just to prove you that it's not just some random data, I can also show that in the daily data. So if you screen for the end of January price here, so this one here in 2015. So let's copy paste that here and set that into relation to the end of January price in 2016. So, and don't be stupid like I am, but do it actually the right way and subtract the 1, you get minus 15.5%, which is exactly that value. So just to reiterate, this is just the 12-month return from this date on in the past or through the past. Same story for this one. So this is just going 1 year back from February 2016, so to February 2015, and so on. So it's just going through every month, and then you have the 12-month return on that. Now, let's get rid of some cells here. Now actually the hardest part in this video is to bring together the 12-month returns with the monthly returns. Why is that? Because you want to have the monthly returns in the same row as the 12-month return. And why is that again? Because you want to see now when Apple was dropping here, what was happening in the subsequent month, meaning in February 2016. So if you hold it over the February month, which is the subsequent month for this look-back period, right? So just in simple words, end of January, you take a look at the 1 year past performance of Apple, and then you make the decision, okay, I want to buy Apple. How did it perform over the whole month, meaning over February? So you want to get this data frame, monthly return, besides this data frame. Or in data design words is, you want to merge this data frame with this data frame based on the date index. And there are 1,000 ways to do that. I'm showing you a super straightforward one, and that is a Pandas function, which is join. So you put the 12-month return data frame on the left-hand side of the join and put the monthly returns on the right-hand side of the join. Why not the other way around? Because you want to have the dates from the 12-month returns, which are obviously starting later as the monthly returns, as you just skip the first 11 months here, as you simply don't have a 12-month returns for the dates before. So you do a left join, starting with the monthly return 12, and then you join on the with the monthly returns on date. And if you're doing that, you will get an error, which is simply due to the fact that both of those have the same column name. So it will return you some stuff like columns overlap, but no suffix specified index Apple. So both are exactly named the same. So if you take a look at monthly return 12, you have the same structure here, Apple and Apple. So you have to provide a suffix so that you actually know when you join the two data frames, then what is what. So you just have to pass an argument here, which is left suffix, and that is our 12-month returns. So I'm just calling them R12 for return 12. And then right suffix is R1, which is just the 1 month return here. So with that, you're getting a super nice data frame like this one here. So you get the ticker plus the 12-month return, and you get the 1 month return directly besides it. Now, super important, I'm just assigning that to talk for together. Could be a better variable name, but I cannot think of one yet or now. So now, important one here. This is not the right structure yet, because think about what this means. This is the Apple return for the past 12 months, and this is the Apple return for the past month. If you consider January, this is the January return, meaning this is already part of this one here. So you cannot take this return because this is simply not the subsequent month return. So if you would check on the momentum strategy based on this date, so if you form the portfolio on this one, you will get this return would be totally wrong. You would get this return, so the February return, based on the momentum portfolio on this date. All right, so super straightforward. What are you doing? You're just shifting this column back by 1 row, and then you have it in the same column. So how can you do that? And how can you do that actually that it's more flexible? So I mean, now it's the Apple ticker, but we want to keep it flexible. For instance, if you pull the Tesla ticker, the Nvidia ticker, or whatever stock you're interested in. So let's keep this column flexible. So I'm using an F string, super straightforward, pass the ticker name, so in this case Apple, and then R_1. So this will just create a column, Apple R1 here, and this column should just shift this column 1 row back. All right, so I'm just pulling the same column here and shifting it 1 row back. Side note, if you want to work with the subsequent 2 month returns, you just have to keep this flexible here, right? Then you shift back 2 months here, all right? But then you also have to work with 2 months returns here in the step before, right? So it's scalable, it's flexible, but I'm keeping it simple for now. I'm just shifting it back 1 month, but just as a note, this is a flexible parameter for your demands. So you shift this column back for reasons I just explained, and then this will end up like this. So how do you read this? Based on this momentum portfolio, based on these 12 past months, you would get this subsequent month return. So this is the return for after 1 month this portfolio has formed. I'm saying portfolio, but obviously this is just buying the Apple stock here. So just the Apple stock has performed, taking the last 12 months into account and then holding it for the subsequent month. So perfect data frame. Obviously you are getting an NaN value here simply because you shift 1 row back, so you don't have a value here anymore. But it also makes sense, right? It's end of January momentum portfolio, and you don't know the February return now, so you simply cannot tell. This, and you should also keep that in mind, is a mark-to-market value, because this is the return in January for Apple until now. So this can change until the end of January, because we don't have the end of January yet. So we're going to drop this NaN value and put it to in place, so just doing it on this same data frame. So with that, you have filtered it out and you have this beautiful data frame, which is a super interesting one in my opinion, because you can already do a lot of stuff with it. For instance, you want to check how often the return is positive when this value is positive, just from an occurrence perspective. So you could do something like that. You check for the 12-month return being positive. So I want to copy paste from here because I'm simply too lazy to type that down here. So you want to check the 12-month return being positive and then the 1-month return being positive at the same time here. So this is what this check is doing, and then you get the filtered data frame. And I mean, you can count or you just take a look at the shape, and that is 49 rows out of 108 rows here. All right. So you could check for the opposite being true. So when this is positive, how many times is this actually negative? So how many times do I mess up following this trading strategy? And you're getting 39 times. So on first sight, it doesn't look too bad, but on the same argumentation, it doesn't look too good, because you just have 49 occurrences that being fulfilled and 39 occurrences that being fulfilled. So it goes in the other direction. Obviously, there are also other use cases, but this are the for you relevant occurrences if you consider a long only strategy, because then you check for the month being positive and then you buy. Or, and this is the other way to do it, you give it a threshold. So you say if the 12-month return is at least 10%, then you're getting less occurrences here. But then you have to check how the performance was. For now, go with the positive, negative check to keep it simple. But just to give you some ideas how many things you can configure here and with what you can play around. You can also play around with a shorting strategy. So you check when this is negative and this is also negative. Only 5 times. All right. So there's a lot of things you can check out here. I'm just giving you some ideas what you can do with that. Next one is to build the actual strategy, and we just keeping it simple. So we say when this 12-month return is positive, we buy and we hold for 1 month. Nothing more than that. And we take everything out of the equation. So we don't have any trading costs. We don't have any slippage. We just model it from a pure theoretical and conceptual base. So strategy, buy when this is positive. Super simple. We take the TOC data frame and just apply some or add some columns to that. First column is the signal column, and this is our buying signal column. And that is, it doesn't get easier than this. You just take exactly this expression actually. You just take this one. So you check where the 12-month return is positive, and then you have your signal column. And you could also just work with an int here. So this is just a Boolean expression now. And I messed up the parentheses here, sorry for that. And then you do a type transformation to an integer, just that you have an easier time. So just to explain what's going on under the hood. So this is a Boolean, and you could just transform it to an integer. So you can just, the idea is you can, whenever you are getting a true signal here, you just multiply this true signal with the return on that month, and with that you can easily just calculate the overall return. So it's just a way to make things simpler. So integer transformation. So how does this look like? So signal 0. And why is that signal 0? Because this one is not positive. 0, this one's not positive. 1, this one's positive. 1, this one's positive, and so on. And now how I'm going to design this is simply, I'm just taking the signal value times the return. So if you have no signal, you don't hold Apple, so you're not getting any return, but you're also not getting any losses. If I have a 1 value here, I'm getting that return. So if I'm getting 2 subsequent returns here, or 2 subsequent ones in a row, I'm getting this return, but also the next month return, as this is still positive. So I'm holding the asset over 2 months. So I can accumulate over all the 1 values here in this case. So you can easily define a strategy return column here. So strategy return, and that is simply our signal times, as I said, the 1 month return. So just going to take this one and change it to 1 month. Just in case at this point you're asking yourself, why is he just messing it up and make it so complicated with this one? The only reason behind that is you want to keep the script flexible. So you want to pass different tickers to this and make it work through different inputs. So that's the only reason, so that you can put in Tesla, Microsoft, whatever you want. So strategy return. And this is, as I just said, super straightforward. So you just multiply this with that. So if you have 0, it's just a 0 return. And then if this is positive, this is a positive return here. So you just have this times this times this times this. So you get the strategy return on that month. And then next you just accumulate those returns, and then you have your strategy return. So you just accumulate, let's call that cumul strat red, and this is simply 1 plus the strategy return. So do I have the column name somewhere here? Yeah, stock strategy return, and then you take the cumulative product. Be careful with the parentheses here. So cumulative product, so just you accumulate the returns over this column here, nothing more than that. So how does this work? So this is just accumulating. So here you have no return, so this stays the same, and then at some point, maybe we are lucky and this is happening somewhere in the first, let's say 20 rows. Yeah, here you see first where you hold it here, or where you buy it and then hold it. And you see here, right, this the month return, so it gets stacked up here. The next month, this is actually a very good example, because next month now you have a negative 12-month return. So your strategy return is still the one month return here, right? Because you don't buy Apple on the next month and have locked in this profit here. And then on the next month, it's being also negative, so you're just having this return and nothing is added up. But on the next month you see that this is positive now, or rather this is positive, sorry, and then you're getting this return. Then this is going to be added up on your return. So it's accumulating whenever you have a position flag as 1 here. Simple as that. So this is how the strategy return is working. And then finally, if you take a look at that, you have quite some juicy returns here. So this is roughly 4xing your capital, as you see. And yeah, that's actually a good one. But if you followed my content, you know that this number is not telling you anything if you don't compare it. And if you compare it to the market return, you will get a different picture here, because it might be that Apple just overly outperformed the strategy by simply using buy and hold. So you could compare that to the market return, which is also something which makes sense. And this is just an attitude thing. So some people say a strategy which is not outperforming the market isn't adding any value. I have a slightly different opinion on that, but it totally makes sense to argument in this way. So let's take a look at the market return, how we can pull that off. So what is the market return? You can just pull it simply. The market return is just the cumulated monthly return of Apple since then. So you can just accumulate the returns for Apple since the first row here. Simple as that. So you need the column and you need to keep it flexible again. So you need to work with this f-string expression here. So just take ticker R1 and then you're getting the cumulative product here. Just making sure I put all parentheses in here. Looks good. And then you get the cumulative market return. So you see dropping off first, then coming back, then dropping off. So you see how it fluctuates here, but in the end, you're getting a way better performance for just buy and holding Apple as following the momentum strategy, right? So people love visualizations. So let's pull that off quickly. Yeah, how can we quickly do that? Let's just plot the market versus the cumulative strategy returns. So PLT plot, torque index, torque, whatever the column was, cumulative market return, label is market return, and then versus the strategy return, how do I call it? Strat return, and then just some copy pasting from other screen because I'm just too lazy to type that all down. So some title, some legend, some grid, some more stuff, and then we need a figure size here so you can actually see something. So figure size just 6. So I hope I didn't mess anything up here with the namings. Let's try to execute and see. And here you have the clear picture. So a very solid strategy, but doesn't get anywhere near the market. So what you can also check is the risk adjusted return, but just by plainly looking at this graph, I already see that even the risk adjusted return for Apple is better for the market return than for the strategy return. Anyhow, it's just a case for Apple. So let's take a look at another asset, and then you can play around for yourself with that. Obviously make that all in proper Python code, so meaning put it in a function, or even better, put this in a object-oriented way, and then just pass the ticker symbols and do some large-scale analysis. So let's take 3M here, so a not so nice performing stock. Execute everything again. So now you see, right, flexible, you have the 12 month, you have the 1 month for 3M. 36 occurrences versus 22. Then calculate the strategy return. Same story as before, cumulative, blah, blah, blah. Then to execute that, no, I didn't. So execute this one again. So, wow, now you see you have the 3M return, and you see that the strategy was outperforming the market return, and you obviously see why, because just keeping you out of the crazy market here, you see the strategy return here is flat and protects your capital in that case, because you always base on the 12-month performance, and you see this literally negative momentum here. Same story for here, but then it comes back and the strategy is catching up. So overall, I think this is a super interesting one, a super intuitive one, and just to add some thoughts or what you can make out of that. So first of all, you can make, where do we have it? This parameter flexible, so you work with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 past month returns. You can make this parameter flexible, so you're working with 1 month holding, 2 month holding, 3 months holding, and so on. So you obviously have to make this one then flexible as well. And then you can do a large scale test on time series momentum across different assets. So I think this should be an interesting one for you. I hope you liked the video, and I thank you very much for watching. And I'm excited and looking forward to see you in the upcoming videos. Cheers. Bye-bye.